Okay, this is my second video on the integration and using integration in calculus. And the last video I explained what the area problem was. This video I'm going to explain why anybody would care how to solve the area problem. So why would we care about finding the area under a curve between two x values? Well, I'm going to start by taking a really simple curve because this is going to make it a little easier. So we've got a straight line. And we're going to imagine that this represents velocity on the y-axis and time on the x-axis. So this represents the velocity of some object, some particle, say, and it looks like the velocity is constant across this period of time. Well, if we try to find this area, what would we get? So suppose I'm finding the area between 2 points, two x values, which are really 2 points in time, right? A and B. Well, what would I have found? Well, let's look at this rectangle a little more closely. So this side down here, the width of the triangle, of the rectangle, is the change in time, right? So that's a change in time between t equals A and t equals B. The height of the rectangle is the velocity, right? It's the velocity the velocity is constant, so it doesn't change. So my area is going to equal V times delta T. Okay, let's hold on to that thought. Let's just look over here. So we've got V area equals V times delta T. Well, what is velocity? Well, at least when we're talking about constant velocity, and we're not talking about velocity varying, and we don't have to think about derivatives and so on, we know that velocity is the change in distance. I'm going to call it S, let S stand for distance, over time, over the change in time, right? You go 50 miles in an hour, then you're going 50 miles an hour, right? Modulo any concerns about changing the time, changing velocities. But velocity is change in S over change in time. So that area of that rectangle that was below the curve there is going to be delta S over delta T times delta T. Oh, well, these delta T's are going to cancel out, and I'm left with delta S. Oh, so what we found when we found that area, well, S is the distance or position, really. I guess position is a better thing to say. It's the position of this particle at time t. What we found was the change in that particle's position, or, to put it more simply, how far that particle traveled over the given amount of time between t equals A and t equals B. So that's why we want to use this, because if we're given a velocity function, this means that given a function v of t, if we can have a way of finding that area, and we're going to talk about how we do that, we can find the change in position even if we don't have that position function. We can use that area curve, that area under the curve, to find the change in position, because the change in position is just going to be the area under the curve.